Hello class, this is a video tutorial on Z-score tables. The common percentages that are calculated are those from the Z-scores of plus and minus 1, plus and minus 2, plus and minus 3, 68%, 95%, 99.7%, and we've seen this already and we've worked with this, this empirical rule. However, it is possible to work with any Z-score. This requires the skill of reading from a Z-score table. Now, in this set of examples, I've chosen to do a slightly more enlarged Z-score table. They're not normally this large, but just to give a brief overview of what this means, if we wanted to find the number or the percentage of scores of the Z-score of 1 and below, we would go to our Z-score table, find 1.0, and it shows that there are 84.134% of scores below a Z-score of 1. As another example, if we wanted to find how many scores are a Z-score of 2.27 and below, we would go to our table, find 2.2, and then go to 7, 2. I've lost it, 2.2, there it is, 2.27. There's 98.84% of scores have a Z-score of 2.27 and below. So that's just a brief overview of how this works. So let's go straight into the first set of scores, and I'm going to do a lot of examples just to really show and contrast and see how to really operate this Z-score table. So here we go. 16,500 students sat a state exam, and the results were normally distributed on a mean of 64.2 and a standard deviation of 9.5. Calculate how many students scored between these two numbers here, and these two and these two. Now, in this first set of questions, you can see that these are just the regular Z-scores of 1, 2, and 3. A Z table is actually not needed for this. But this is a good chance to see some possible notation that you will encounter. So now when it says how many students are between, it's written as follows. The probability or the percentage of scores 54.7 greater than X and less than 73.7. Now, this notation is exactly what it's saying here. How many or what percentage of scores are between less than 73.7 and greater than 54.7. So it's how many are in between these. But this converts to the probability, and we're now going to find the Z-score of each of these. So take a look. Using our Z-score formula, we have a mean. So the mean, let's write it up here. The mean is 64.2, and the standard deviation was 9.5. So take a look. It would be 54.7 minus the mean over 9.5. Take a look. This is a Z-score of -1. And the other one's actually going to be a Z-score of +1, but just to show you here, if we put in 73.7, we get a Z-score of 1. So notice now, this notation will become as follows. So the percentage of scores are between 54.7 and 73.7 is equivalent to or equal to the percentage of scores of a z-score between 1 and -1. This is the one that we're familiar with. That's literally in between 1 and -1. Z-score between there. We know that to be 68%. So this is just simply 0.68 times 16,500. And just easy multiplication from here. 16,500. We get 11,220 students. So 11,220 students had a z-score between -1 and 1. Or we could say this many students scored between 54.7 and 73.7. Let's finalize this first set of questions. So here we go. Let's get familiar now with all the notation. So between a score of these two, we can write this as the percentage, 34.7, is less than x, is less than 83.2. So notice how this is the x, or the score, is between these two numbers. So this is equivalent to percentage, and we're gonna convert this now into z-scores. So 34.4 minus the mean of 64.2 over 9.5. Sorry, 35.7, my bad. 35.7. Sorry, that gets us a z-score of -3. And 83.2 is 2. So notice how we're really changing this notation into the percentage of z-scores between -3 and +2. Once again, we've seen this before. -3 up until +2. For this, we're going to go back to this regular one here. So we're looking at from -3 to +2. To do this, we find -3 to halfway. That is half of 99.7. So 0.997 divided 2. That halfway is 49.85%. And then we're going to go from 0 up until 2. And that is half of 95. So 0.95 divided 2 is 47.5%. Adding this together, adding these together, we get 97.35. So altogether, this gets us 97.35%. So that is the number we are going to be working with. So the percentage here is 97.35. So that's simply 0.9735 times 16,500. Okay, so using our calculator, 0.9735 times 16,500. That gets us 16,063 students are in between that. Just rounding up to the nearest whole. And for the last example here, 93.7 and 92.7. So once again, this is in between these two numbers. So the percentage, 73.7, is less than x, less than 92.7. And we're going to convert this again into our z-scores. We can already see this is a z-score of 1. And 92.7, you can probably guess is going to be a z-score of 3, but let's double check here. 92.7 minus 64.2 over 9.5. That gives us a z-score of 3. So this is from 1 up until 3. Well, for this just goes back to the regular z-scores that we're familiar with. This is just going to be, so take a look. It's from 1 until 3. So this is half of 99.7 minus half of 68%. So take a look. That would be 99.7 divide 2 minus 68% divide 2. That gives us 15.85%. There are this many students in between those scores. It's going back. So 15.85% times 16,500. So 15.85% times 16,500. Whoops. That gets us 2,615 students. Okay, so I hope that's giving you an insight into, well, before we go into the z-scores tables, I hope this is familiarizing you with this notation. But notice how whenever we get these plus and minus ones, 3s and 2s, we can always just go back to our original empirical rule, or this regular 1, 2, and 3 z-scores. Hope to see you in the next video where we take on the actual z table. Hope to see you then, and best of luck.